Number 2 on the target 5 and 6 worksheet. I'm going to plot these points, and for this problem I'm going to do all the side lengths of the triangles using the distance formula. Example 1, or number 1, video, I did the entire problem using the Pythagorean theorem. You can use either strategy, doesn't really matter. So for number 2, A is at negative 4, 1, B is at negative 2, 4, and C is at 2, 2. And I want to classify the triangle as right, acute, or obtuse. It looks like it could be right. I could actually use the slopes from A to B and B to C that say that it's not a right triangle because the slope from A to B is 3 over 2. And the slope from B to C is negative 2 over 4 or negative 1/2. And those two slopes are not perpendicular slopes, which means they're opposite reciprocals. So it's not a right triangle, but we'll see that. So first, let's find AB. I'm going to do from A to B in blue. So I'm going to say AB equals, or my distance from A to B equals the square root of. I'm going to work out the distance formula. It doesn't matter if you start with A or B in this case. So I'm going to do negative 4 minus negative 2 squared plus 1 minus 4 squared. So that's x2 minus x1 squared plus y2 minus y1, or x minus x squared plus y minus y squared. That equals the square root of negative 4 minus a negative 2 is negative 4 plus 2. So negative 2 squared plus negative 3 squared equals the square root of 4 plus 9, which is the square root of 13. So AB is the square root of 13. I'm going to make that smaller. Now I'm going to find BC. Do that one in red. BC is equal to the square root of the difference in the x's, so negative 2 minus 2 squared plus 4 minus 2 squared. That equals the square root of negative 4 squared plus 2 squared, which is the square root of 16 plus 4. That equals the square root of 20. And that does simplify. Square root of 20 is 5 times 4, or square root of 5 times square root of 4, to 2 root 5. And this is all BC. It's actually going to be easier for me to work with the square root of 20 for this problem. So I'm going to write the one that is not simplified all the way. And then I'm going to kind of move this out of the way as well. So I have 2 of the sides. Let's find the third side, AC. I'm going to use green. So AC equals the square root of, so x minus x is negative 4 minus 2 squared plus y minus y, or 1 minus 2 squared. So AC equals the square root of negative 6 squared plus negative 1 squared equals the square root of 36 plus 1, or the square root of 37. That is a prime number, so we'll leave it how it is. So now I have all 3 side lengths. Again, I'm going to kind of move this out of the way. So on this problem, I used the distance formula to find all 3 side lengths. Now I can take the largest one, which is in green, the square root of 37, and I can use what I know from the Pythagorean theorem and its converse to work that out. So I want to compare the square root of 37 squared to the other 2. So compare that to the square root of 13 squared plus the square root of 20 squared. Well, the square root of a number squared is just a number. So I'm really comparing 37 to 13 plus 20. 37 is greater than 13 plus 20, because 13 plus 20 is 33, because c squared is greater than a squared plus b squared. That means that this triangle is an obtuse triangle.